Okay, welcome to topic 8.3. So in 8.3, we'll be talking about three-dimensional trigo problems. Okay, so for a 3D problem, the triangle will look slightly different. So the best way for you to solve the question for 8.3 is to view it in different plane. What do I mean by viewing it in different plane? So for example, you can always split something like this to see it from the side view or your top view. Okay, when you draw it when you see it in a different perspective, the question becomes a lot easier. Okay, so moving on to the first example, we have a pyramid and it's drawn in 3D. Okay, it looks quite complex, but we will continue the question first, and then I will slowly teach you how we go about solving this kind of question. Okay, so a great pyramid has a square base, so all the base sides are the same. Okay, with sides of 232.6 meter long. The distance from the top of pyramid E to each of the corner is 22.12 meters. Find the length of AF. Okay, so for AF, it is this one over here. So the one highlighted in green. Okay, how do we find AF? Okay, from this image, it's a little bit hard to tell, but because the base is a square, this is actually a right angle triangle. And then I can actually form a triangle with A, B, and C. Okay, so if I see it from the top view, I remove everything else. What I will get is a triangle that looks something like this. Okay, so this is just purely top view. Okay, this one and this have the same length of 232.6 meters. Okay, and then this is my A, this is F, and this is C, this is B. Okay, this is my top view. Okay, do you see that after drawing the top view, it becomes a lot easier to find AF because I can just use Pythagoras theorem to find the length of AC, and then from there I can just divide by 2 to find AF, compared to seeing directly from the figure, which might be confusing. Okay, so that is the general step to solve questions in 3D. Okay, you draw your 2D figure and work out from there. Okay, continuing. Using Pythagoras theorem, I know AC square equals to 232.6 square plus 232.6 square. AC equals to square root of whatever is above, 6 square plus 232.6 square. Okay, if you don't know how to combine both of them, just leave it like this. Okay, then you type the whole thing into your calculator. Okay, 328.946. Okay, I will leave it in exact first. So to find AF, okay, AF is just half of AC, which equals to half over half times 328.946. Okay, which will give me 164.47, and then I round off to 3SF. I get 164 meter. Okay, moving on to part B. Find the length of EF. EF is the height of the pyramid. Okay, it is so EF, it is the height of pyramid. So actually over here, it is a right angle cause your ABCD is on the flat ground. Okay, and E is the height. Okay, so this one is from your previous topic. Okay, so let me draw the triangle in 2D. So this is my side view. Okay, this one will be EF. Over here is my AF. Okay, I use the same color to label so it's easier for you to see. Okay, so this is F, this is E, this is A. Okay, what else do I know? This is a right angle. This is 164.47. And this is, the side is 221.2. So this is 221.2. Okay. So I want to find the length of EF, is the purple one. So I can actually use Pythagoras theorem. Okay. There is no need to use any cosine rule or sine rule because I only have two sides. Okay. So what I will do, 221.2 square equals to 164.47 square plus EF square. Okay, I make EF my subject. Okay, I bring 164 over. Okay, so EF square equals to 221.2 square minus 164.47 square. Okay, I bring my square over. So I square root the right side. Minus 164.47 square. This will give me 147.915, which I can round off to 148 meters. Okay. Next question. I want to find the angle of elevation of E from A. So I go to A. My angle of elevation is over here, the one in red color. Okay, so over here, because I already know the sides, I can just use my Picasso. I have adjacent. I have my hypotenuse. Okay, I will just use cosine angle EAF equals to 164.47 over 221.2. Okay, angle EAF equals to cosine inverse 164.47 over 221.2. Okay, so this time I just bring my cosine over, become cosine inverse. When I type into calculator, I'll get 41.966, which I can round off to 42.0 degrees. So it is in 1 dp. Okay, so actually in the previous step we have found EF. So technically we have opposite also, but I would recommend to use cosine because first, hypotenuse is a confirmed correct answer because it's given by the question. And then the AF, we found it in part A. Whereas EF, we found it in part B. So if anything wrong, there's a higher chance for EF to get wrong. So I use values where you have a higher chance of being correct. Okay. So moving on to the next question. Example 2. Write down the expression of H. Okay. I think everything else is already in the diagram, so there's no need to read. Okay. So write down expression of AC. Where is AC? Okay, AC is this one over here. Okay, how do I find AC? So I will use this triangle on the left. Okay, I'll highlight red. Okay, it's a little bit hard to see, but let me draw in 2D first. Okay, so when I draw it out, it is actually something like this. Okay, this is a right angle. This is my 30 degrees. Okay, this is A, this is C, and then this is T. This is my H. Okay, so now I have my opposite, which is my H. I have to find my adjacent. Okay, so I can use tangent. Okay, so tangent 30 equals to O over A. So it's H over AC. Okay, I can make AC my subject, and then I shift my tangent 30 over, so it becomes H over tangent 30. Okay, remember first step is always to draw it in 2 dimension first, so it's easier for you to see. Okay, next I want to find CB or BC. Okay, so it is the one highlighted over here. Okay, so I'll draw this at the side. It will look like this. So this is the side view. Okay, this is a right angle. This is T, this is C, and this is B. Okay, this will be 46 degrees. Okay, from this one, I will use the same thing. I want to find my H. Sorry, I have H over here. I want to find what is my BC. So I have my opposite. I have adjacent. I'll use 2, which is tangent. So tangent 46 equals to H over BC, which I do the same thing as the previous question. So it will be just H over tangent 46. Okay. Moving on to part B, there is a hence. So I have to use my previous part to help me. Okay, they want to find the value of H. So I have to find something where I can link both AC and BC so that I can use my H. Okay, so actually what I'll be doing is I will use this triangle at the bottom. Okay, the one in green. Okay, so although it doesn't look like a right angle triangle, it is actually a right angle triangle because this is, okay, here is actually my east, this side is actually my west, here is my south. So actually the angle over here at C is a right angle. So I will draw the triangle out. Okay, I'll draw from top view. Okay, so it's easier to see. Give me a while. Okay, never mind. So this is actually a right angle triangle. This is 61.6. This is B. This is C. This is A. So triangle ABC. What else do I know? Okay, so with this info, I can actually use my Pythagoras theorem. So AC square plus BC square equals to 61.6 square. Okay, now I substitute what I know from the previous part. Okay, over here I have to write slightly smaller. Okay, so AC is H over tangent 30 square plus H over tangent 46 square equals to 61.6 square. Okay, so now I will bring my square into the bracket. So I'll get H square over tangent 30 whole thing square. Okay, do not write the square directly because the examiner may think that you are squaring the degree. Okay, so you must include the bracket. Over tangent 46 square equals to 61.62. Sorry, 61.6 square. Okay, from here I will factorize my h square out. So it looks something like this. 1 over tangent 30 whole thing square plus 1 over tangent 46 square. Okay, my right side is still unchanged, so it's 61.6 square. Okay, I'll make this slightly smaller. Okay, so after this step, I can bring whatever is in my bracket over to the other side. So h square equals to 61.6 square whole thing divided by whatever is in the bracket. Okay, so it's 1 over tangent 30 whole thing square plus 1 over tangent 46 whole thing square. Okay, I will type this whole thing into my calculator. Okay, I get h square equals to 964.909628. Bring my square over. Okay, I type this into calculator, I get 31.06299, and then I round off, it will give me 31.1 meters. Okay, so moving on to the next step, the next question, they want me to find the bearing of B from A. Okay, so the bearing of B from A, okay, so I'll go to A first because they say it's from A. I'll draw my north line. Okay, if you are using the diagram, you'll be slightly different. Okay, but since I already draw this one already, I'll show you on this one first. So this is the bearing that they want to find. If I'm using the diagram straight, take note that my north line, it is slightly at an angle. Okay, and then I go all the way to B. Okay, so take note where is your north facing. Okay, so from this one, I can use the previous part to help me. So from part A part 2, I have BC equals to H over tangent 46. Okay, which equals to 31.06299. So I found this in the previous part, over tangent 46, which equals to 29.997. Okay, so this is for me to find my length of BC. It is 29.997. Okay, so now I have two lengths. I have my opposite, I have my hypotenuse. I can use my torcaso. I'll use sine CAB equals to 29.997 over tangent 46. I bring my sine over. Here come sine inverse 29.997 over tangent 46. I get an angle of 29.14, which I can round off to 29.1 degrees. Okay, but since they are asking for bearing, I cannot just leave it as 29 degree. So the bearing is equals to 029.1 degree. You need to put it in 3 digits, and in this case 1 decimal. Okay, for those of you who can see it directly, or because in part A we have CB, we also have AC. Okay, so you have CB and AC. Can actually just straight away use tangent CAB. Okay, so your H will cancel out. Okay, for those who don't know what I'm talking about, just stick to method 1. This is method 2. Okay, actually if I use my part A answer directly, I use tangent, I get my H over tangent 46 over H over tangent 30. Okay, so this is my BC over AC. Okay, so this is BC over AC. Okay. The reason why I don't recommend this method is you need to know how to cancel out to use this. Okay, so actually H and H can cancel. I get 1 over tangent 46 over 1 over tangent 30, which I can type the whole thing into my calculator, and I will get 29.141, which equals to 029.1. Okay, this is if you can see how I can cancel out H. But if you are not confident in that, just stick to the original method. Okay, next one, they are trying to find the shortest distance of C from AB. Okay, when I talk about shortest distance, I need to have a right angle line from AB that connects to C. Okay, so let me redraw this. So this A, B, C, correct? Yeah. Okay, and I know this is 29.14 degrees. Twenty-four, 29.1. Okay, so I need to have a right angle here. So it is the shortest distance from AB to C. Okay, with that, I realize I have a right angle triangle, which I also have my AC. Correct, I have the length of my AC, which is just my part A part 1. Okay, so let me write down, let me find the length of AC first. AC equals to H over tangent 30, right? Okay, AC equals to H over tangent 30. Can substitute my H in, which I found in B part 1. So it's 31.06299 over tangent 30. Okay, so when I type into the calculator, this will give me a length of 53.8026. Okay, so this is 53.8026. Okay, I have my hypotenuse. I need to find my opposite. Okay, so it will be, I have O and H. I will use sine CAB equals to O over H, which will be AC. Okay, I make O my subject. So it's AC sine angle CAB. AC is 53.8026 multiplied by sine 29.14. Here I type this into my calculator. I get 26.1989, which I can round off to 26.2 meters. Is GSF. Okay. Okay, moving on. I will go to example 3. Okay, so before I go to example 3, so the greatest angle of elevation of a top object is when the observer is nearest. So it's as close to the object as possible. Okay. And then the shortest distance is the perpendicular distance. This is what we have done in the previous question. Okay. So example 3, we have a few with the angles over there. And here everything is annotated already. Calculate the shortest distance from C to AB. Okay. From C to AB. So I will draw a perpendicular line over here. So same thing, I'll just draw a triangle over here so it's easier to see. Okay, so this is 90 degree. This is my C, this is E, this is A. So this is the triangle that I will be using. Okay, it is the one highlighted now. Okay, so over here I have the angle of 60 degrees. I also have a side of 65, my hypotenuse. So if I have my H, I can find my O. Okay, CE. So I will use sine because I have O and H. Sine 60 equals to CE over, okay, I let this point be E. Okay, sorry about that. I have CE over AC. Okay, so sine 60 equals to CE over 65. I make CE my subject. I bring my 65 over. I get 65 sine 60. This will give me 56.291, which I can round off to 56.3 meters. So it's 3SF. Okay, next question. We are talking about the greatest angle of elevation. Okay, so greatest angle of elevation is the from the shortest distance possible. Okay, for example, okay, let's say you are at Marina Bay Sands, and then this is the building. Okay, when you stand very far away, say I stand over here. Okay, I look at the top of Marina Bay Sand. It looks something like this. Okay, and this is my angle of elevation. Okay, I compare it to when I stand very close. Let's say at this purple dot. I look straight up. Do you see that my angle of elevation is way greater? Okay, so to find the greatest angle of elevation, I have to go as close as possible. So in this case, there is a vertical tree at point C. So at the top over here. Okay. And I'll find the greatest angle of elevation. I have to go to the closest distance. So in this case, on DB, the closest distance is at point E. Okay, so I will redraw the triangle. So I have a new triangle now. This is point C, this is point E. Okay, what I'm doing is actually I have a tree over here. Okay, and then I have this new triangle that I am actually drawing here. So I have E, I have C, and then the top of the tree I'm just gonna put T. Okay, the height of the tree is 16.2 meters. They want me to find the angle of elevation. Okay, from part A, I also found what is EC already. It's 56.291. Okay, this is the shortest distance I have from BD or DB to the tree. Okay, so using this triangle, I have my opposite, I have my adjacent. I can use tangent. So tangent angle TEC equals to 16.2 over 56.291. Okay, I bring my tangent over. Become tangent inverse 16.2 over 56.291. Okay, I type into calculator. I get 16.055, which I can round off to 16.1 degree. Okay, so this is 1 dp. Okay, all angles will be in 1 dp. Okay, from here, actually I'll move on to all the way to the last question. All the question in between you can try. Yeah, but I'll move on to the last question. So this is a O-level question. Okay, the diagram below ABCD shows four corners of a horizontal rectangular view of ABCD. The corner B is 82 meter away from A, bearing of 021 degrees, and C is 173 meters away from A. Okay, so over here just 0, 2, 1. Okay, a hot air balloon is hovering at point E, which is vertically above C. The angle of elevation of balloon is 35 degree from D. Okay, so from D, the angle of elevation, this is 35 degrees. Okay, so since this is a rectangle, I know this is 82 meters also, because the other side is 82 meters. Okay, find the height of balloon above C. Okay, so I will actually use this triangle over here. Okay, I'll use ECD to calculate. Okay, so let me draw the triangle. Here I have E, I have C, I have D. This is 82 meters. This is 35 degrees. Okay, I want to find what is my height, which is EC. I have my adjacent. So I can use tangent 35 equals to EC over 82. I make EC my subject maybe 82 tangent 35, which equals to 57.417. Okay, and I round off, I get 57.4 meters. Okay, says 3 SF. Okay, now they want me to find the angle of elevation from B. Okay, so B is over here, but I do not know my length of BC. Okay, but it's okay. I'll draw my triangle first. So I'll draw triangle BEC. Okay, let me highlight in red. Let me draw this. Okay. So I have B, I have C, this is E. Over here I found in my last part, this is 47.417. Okay, angle of elevation I want to find, I don't know yet. Okay, but I can find my BC. Okay, because I have my diagonal length and I have one of the sides, I can use my Pythagoras theorem. Okay, so I have 173 square equals to 82 square plus BC square. Okay, I make BC my subject. I bring my 82 over to the other side. Okay, so I have 173 square minus 82 square. Okay, BC equals to square root 173 square minus 82 square. Okay, this will give me 152.3318. Okay, so now I have my BC, which is 152.3318. I can use my Tuakaso. And my opposite, I have adjacent. Same thing, tangent, angle EBC equals to 57.417 over 152.3318. Okay, I bring my tangent over. Become tangent inverse. 57.417 over 152.3318. Okay, I type this whole thing into a calculator. I get 20.652, which I can round off to 20.7 degrees. It's 1 dp. Okay, moving on to the last part. Okay, a bird is hovering 40 meters above the field. It spot its prey at the angle depression of 63. Calculate the distance the bird must fly to catch its prey. Okay. So let me just draw a triangle. Okay, let's say here is the bird. Okay, it is 40 meters above. Okay, the angle of depression. So I draw my horizontal line. 63 degree downwards. 63 degree. Okay. Assume here is the flat ground. So here is my field. Okay, and this red color line here is where the bird will fly. Okay. So actually, if I look closely, I have a alternate angle. Okay, I know this is 63 degree. Okay, I have my opposite. I have an angle. I can find my hypotenuse. Okay, so actually this question not really linked to what is drawn above. Okay, so I let this red color be D, so it's the distance. So I will use sine because I have over H. I have O and H, sorry. So it'll be 63 equals to O over H, 40 over D. Okay, I make D my subject. I bring my sine 63 over. Okay, I type this into calculator, it'll be just 44.893. Okay, I round off, I get 44.9 meters. 3 SF. Okay, if not, that is it for this topic. Okay, to summarize a little bit, to solve any 3D diagram, the best way is to break it down and change it into a two-dimensional diagram first. Okay, so you draw either the side view or top view before you proceed to solve normally like your previous few topic. Okay, if not, that's it.